Dear class 10 student, we'll continue the chapter periodic classification of elements. We'll do the in-text questions first. For in-text questions for Debabrata's triad, Newton's law of octet, and Mendeleev periodic table. So let's take the questions, in-text questions. So the first question is, it is in page 81. Just go to page 81. Did Debabrata's triad also exist in the column of Newton octaves? So answer, I have done it. Did Debabrata triads also exist in the columns of Newton's octave? Compare and find out. Yes, answer is yes. Debabrata triad also exists in the column of Newton's octaves. One such column is lithium, potassium and sodium. Okay, so we'll go to next question, that is, what were the limitations of Debabrata classifications? Limitations of Debabrata classifications is that all known elements could be classified into groups of all known elements could be classified into groups of triad. This is not triad, this is triad. Triad. Okay, on the basis of their properties. Now we go to question number 3. What were the limitations of Newton's law of octave? What are the drawbacks? Okay, I have already given, but if still you write down the answer. Limitations of Newton's law of octaves. Number 1, you can see it was not applicable throughout the arrangement. It was applicable up to calcium only. So we can apply up to calcium only. The properties of the elements listed after calcium shows no resemblance to the properties of the elements above them. Okay, so let's check out. See here, so this is the Newton's law, Newton's octave. So this is valid up to this element only. Okay, up to calcium. After that it does not follow. Sometimes cobalt and nickel and place in one group are placed together, and here celeron and lanthanum, these two are placed in Ce and La, they are placed in one. They are placed together. The position of cobalt and nickel group of cobalt and nickel groups of elements of different properties could not be explained. Okay, why these are grouped, it cannot be explained. Number 3, placing iron away from cobalt and nickel could not be explained. Right? So we go to page number 85. Let's see the question. Page number 85. Page number 85 covers Mendeleev's periodic tables question answers, in text question answers. So use the periodic table, the formula for oxides of potassium, carbon, aluminium, silicon and barium. Okay, let's see. So I have done it. Use the Mendeleev's periodic table to predict the formula Formula for oxides of following: potassium, carbon, aluminum, silicon, barium. So potassium is in group 1, therefore the oxide will be K2O. Carbon is in group 4, therefore the oxide will be CO2. Aluminum is group 3, therefore the oxide will be Al2O3. Silicon is in group 4, therefore the oxide will be SiO2. Barium is in group 2, therefore the oxide will be BaO. Okay, next question in page number 85. Beside gallium, which other elements have since been discovered that were left by Mendeleev in the periodic table? Any two. So we have scandium and germanium. Okay. What were the criteria used by Mendeleev in creating his periodic table? What were the criteria? Mendeleev's, so spelling is wrong here. Mendeleev used atomic mass of elements as the unique criteria for the elements. He proposed that the chemical so you remember this atomic mass, okay, for Mendeleev. Okay, he proposed that the chemical properties of elements are the periodic function of their atomic masses, and thus he arranged the elements in increasing order of the atomic masses. Now we go to question number 4. Why do you think the noble gases are placed in the separate group? Noble gases in elements okay. Noble gases in elements here we have noble gases are here. Inert elements, okay. Elements. So their properties are different from all elements, therefore the gases are placed in separate groups. Okay, so we will next session we will do modern periodic table. We are done for today. Thank you very much.